Okie doke. Let's continue till 6. 47 more minutes. Yes, so we cannot have a default guy on the left and an explicit on the right, because then we cannot use the default argument. Well, because then the only way we would be able to call it is by explicitly specifying the default argument. Yeah, exactly. We wouldn't be able to use the default argument because we have to specify something to the right, therefore we have to specify the left. Must be declared before use. Yeah, makes sense. Yeah, it must be declared, meaning that the compiler needs to see it. We can't say, hey, there's a default argument in the fucking CPP definition, and the compiler sees a for declaration, but without a declaration to the default argument. Argumente. Yes. For a function with a for declaration and a definition, the default argument can be declared in either or. But I don't think that's the case, because then the compiler will not be happy, because it will say, hey, does not take 0 arguments, or in this case, does not take 1. So, well, this wouldn't. What? Hold on. Yeah, we specify this guy, and then we do this. So we could call just print 3. Hannibal? Oh. Static. Okay. I don't think that's the case, that it can be declared in the function definition, because the definition, if it's declared in the definition and not the for declaration, unless we're defining it in the same file, it won't work. So if we're defining it at the bottom of main, for declaring it at the top of main, using it in main, it can be in the definition, because the compiler sees, hey, oh, actually, could it? I don't even think it could, because the compiler would see the for declaration and say, hey, yo, no default arguments, because the definition sees it. Is it actually the case that you can do it like that? Let's find out. So we'll get our main going. And we'll say void do thing, and it needs int thing is 5, and then it does nothing. Okay. Oh, this is a for declaration, by the way. Oh, yes, for declaration. This is int thing. Okay, for declaration. And then later we have void do thing, int thing. Oh, well, yeah, okay, we're not redeclaring the thing, so we're saying that it takes an int, but we're not putting the default argument in twice. We can only declare the default argument once. And so let's say the default argument is 10. Okay. And then it does nothing. Ooh. So sure, we'll say thing. So if I call do thing, Ooh, does not work. Because the compiler sees, hey, buddy, before you've even called this guy, he takes an int. You better give him an int. We can do this to check. Okie dokus. It's over and then into, yes, cool. So we are stepping, wait, over. What the fuck is this? What is this? What is it saying here? Yo? Oh, I guess it doesn't watch. Really? Oh, there's no fucking variable to watch. Hello? What am I saying, dude? So we need to be looking into the functions. We need to step into. And now we're watching thing. So thing was 10 at first, and then it became 1. Yes, exactly. The problem here is that, oh, we cannot use a default argument in the definition, bro. Because the for declaration does not have it, therefore the compiler won't let you. So this, I don't think this is true. I think it has to be the for declaration. So we have a for declaration, and then we have a compiler error. Yes, because we're re-declaring, defining, same shit. Or yeah, I guess it is redefining. The declaration is fine. We can say, hey, y exists here, y exists here. All right, we're cool. We can't do the default argument in both cases. We cannot redeclare the default argument or redefine the default argument. Must also be declared in the translation unit before it can be used. Yes. So if we did it not in the for declaration, but in the definition, things that use the definition and don't see the for declaration are cool. Things that see the declaration and then see the definition are cool. Things that only see the for declaration are not cool, because when it's defined only in the definition, or when it's defined in the definition instead of the declaration, no bueno. Why? Because the compiler hasn't seen the default argument yet. For declaration here with no default argument. We can't, if y is the default, or if y is the default argument and we're initializing this x with 3 and then using whatever y already has, well, no go, because the compiler hasn't seen this. Hasn't seen this by this. Do it in the for declaration because it has probably been seen and included before use. Yes. So yeah, in the header file, do it. But then in main, in this case, we'd probably want to say, hey, by the way, this guy's default argument is 4. Because we're not going to see this in here. We're just going to compile it. In the above example, we're able to use the default argument because, hold on, we're able to use the default argument for print, because main.cpp has the for declaration that has it. Yes, exactly. Yeah, what? Hello? If the function has a for declaration, put the default argument there. Otherwise, put it in the definition. Meaning, oh, so that's what you're saying. In the event you're using a for declaration, you cannot put it in the definition. But if you're only, well, yes. You must put the default argument there. But if you're using a definition and then calling it, then you're cool. Because then the compiler has seen the definition. Default arguments and function overloading. How would this work? This is getting complex. My brain's going to hurt. So, we call a function and the default argument has something and we call it. Then does it even change anything? I'm going to scroll down. It doesn't seem like it changes much if there's not much here. I didn't read that. So if we have a function, if we have an overload that takes an int, and have another load that takes an int, another overload that takes an int, that has a default argument, no go, because it's the same signature. Right? Yeah, does it even change anything? So for example, we can call it as a string. We can pass it a string view. Or we can call it with a character. So if we call it with a character versus a string, different things. We can call it with nothing, and it will default to be the character. Why? Excuse me. Because the empty... Oh, so what happens if we have one call that has none, and then we have a default argument? In both cases, the default argument would be an exact match because it defaults. But then there's the void, or the one that takes no parameters, which would also be an exact match. What do we get? Oh, okay, we're cool. All right. Oh yeah, we don't have main yet. So what happens if we call do thing? Ambiguous, yes, because both of these, that's what I thought. Because the void one, or the void taking one, the one with none, is an exact match because we called it with none. But the one with the default argument, we called with none, is also an exact match. Ambiguous. Is that what it's going to talk about here? Maybe not. Okay. Oh! Oh. Yep. And then defaults to get the character. Function call actually prints character, or prints the character by default because the compiler will substitute. But in this case, we're doing nothing, and by default, it's a blank character, or it's the white space character. What about this case? We can do x, we can do int, and then a default int, and then another, and then another. Well, what happens if we just do it with x? Do we get... If we just pass it that, does it do the default, or does it... Yeah, so if we did the same thing, except instead of being empty ones, we had actual arguments, void do thing, and then it has an x and x, and y is 5, x, y, void do thing, and x, okay. And then if I call it with 5, ambiguous again, why? Because, are we saying 5 and then this, or are we saying just 5? We don't know. Yes. The default values are not part of a function signature, so they are differentiated overloads, meaning yeah. What do you mean? Default values are not part of a function's signature. So these function declarations are differentiated. What do you mean they're differentiated? What are you talking about? I don't know what you mean. It just means that, hey, if we had another one in here that was print x and then y, and neither had a default argument, it would conflict with this because the signature is print int. Because they're not a part of it. Yeah, makes sense. Therefore, it can still conflict with other ones that don't have the default argument. Because then if we call it, it doesn't know if we're saying, hey, replace this guy, or explicitly initialize the other one that you must. May lead to ambiguous calls. Yep, so if we have int x is that, double is that, and then we call it with nothing, which one is it going to default to? We don't know. Makes sense. And there's no precedence for which is defaulting first. And then here's another example. X and then xy. Well, if we just do x, we have no idea. What's triple ambiguous? Because we don't know if we're saying, hey, just do x, done. Or if we're saying, do x and then leave y default. Or do x and leave y default. Which one? We have no clue. If we say 1 and 2, cool. If we say 1 and 1.5, we're cool. Because it knows there's only one int double and there's only one int. Therefore, we cannot use this. So, ambiguous calls. In this case, where we did mean, or where we mean to call this or this, it isn't obvious how we would do that. So what would we do if we said, maybe there's a way of specifying to not use a default. Like saying int x and then not the extra shit. But in this case we can't because the default conflicts. Called through function pointers. Default arguments are not considered using this method. Meaning, provides a workaround to call a function that would otherwise be ambiguous. Default arguments are not considered using this method. Oh, is this because you're calling a function exactly where it is? So you're able to more specifically specify the overload instead of having your call simply be, so you can call the function through a pointer to it, that one, instead of saying, I'm going to call one of the overloads with this. And then the compiler has to say, you mean this. Instead, I say, that one. And then the compiler doesn't say, oh, you mean this. It says, well, duh. That's the only one. That's the only one with the pointer. It's the only one located at that address. There's only one x at 0xA5B fucking 2. Okay. Function templates. A function to calculate the maximum of two numbers. Okay. So you could in what the questions here afterwards, after saying two numbers, meaning what if we want the max of a this and a this, or a this and a that, or that and a that, and that and a that? Like, what if we get an unsigned one? If we get an unsigned one, then maybe we have to convert the unsigned value first. So if I looked at the int summation one and the unsigned int summation one, we might want to do something with the unsigned int one, or have something at the end of the function saying, hey, by the way, there's an unsigned int in here. Or like, you call it, the regular int one says this, the other one says this. I don't know if that's right here, though. I mean, that would be if we had two different overloads. But templates might be different. Templates are different, but well, it might be, yeah. Okay. Calculate the max. Oh, we're not doing a sum here. We're just doing the max. Okay. So, is x less than y? If it is, return y. Why the fuck would you do this? Why wouldn't you say return y is greater than, or x is greater than y, xy? Why would you say x is less than y, start with y? That is a retarded ass ternary operator. What the fuck? We use that because that. Okay, maybe that's why. I would still say y is less than and then do x, but we use this instead of that because standard max uses less than. Oh, because if we're including the IO stream, then wouldn't you still get a confliction? Or a name conflict? Maybe not? I don't know. Okay. I mean, I don't know why that's relevant. We can pass different values into the function. The types of the parameters are fixed, so we can only pass in ints. So if I cast it, or if I call it with two floats, then the floats have to be converted into ints implicitly or explicitly if I do it, and then we get the shit. Instead of getting different stuff depending on what I pass in. It only works well for integers, types that can be promoted, thus their values preserved, yes. It's like characters, booleans, smaller unsigned ints, uint 8, for example. Uint 16, for example, if we're talking 4-byte ints here. The max of 2 double values. C++ requires us to specify the type of all solution, but then we're gonna have, yeah, it's gonna be a burden because now we have more shit to maintain. Because C++ requires us to specify the type of all parameters. If we want to do this with two doubles, we have to create an overloaded version with doubles. Then I can just pass it doubles and it'll call the right one. Cool. Okay. Exactly the same. So we're kind of violating DRY, don't repeat yourself. The code for the implementation of the double version of max is exactly the same for the int. Well, yeah, it's the same shit. It's just that we're passing in different parameters. Because it's operating on different types, which means it's operating on a limited type of value. We use this if we're passing in this value. If we want to do max 3.4 and 5.2, we have to do the double or a float version. We can't do a fucking int version. Unless we want those to be changed to 3 and 5. Or 4 and 5, maybe. I don't remember what I said. Yes, exactly. A clear violation of dry. Exactly. Yeah, recipe for errors because you're copying the same shit into multiple ones. Yeah. A less obvious challenge as well. If we want to use the max function, we call it with an argument type that the max did not anticipate. Meaning, so we did one that we didn't expect, so you call it with unsigned ints. Oh, well, fuck. If you called it with a regular ass unsigned int, a uint 16, or a uint 32, one that does not numerically promote. Actually, sorry. Signed, unsigned. There's no promotion here. It's numeric conversion. So if you passed an unsigned anything, it's not getting promoted unless you did const expression maybe, but it's still numeric conversion. In this case, if you passed in an unsigned int, it's numeric conversion to get an int, same as to get a double. So both of we get ambiguous call. Ambiguous call. Yeah. And now you have to fucking do another overload for an unsigned int one. What if you have one that just handles all the shit? So you do boom boom and then handle all the rest. What we're missing is a single way that works with arguments of any type. Normal functions do not work. We have another feature. Whole feature. Holy shit. That way we can have one function that handles different types of parameters without having to convert them all to the same shit. Templates. Holy shit. Simplify the process of creating functions or classes that are able to work with different data types. So instead of having to make two functions that work with different data types, or one for one, one for another, we can do one for all. Yep. A template. It describes what a function or class looks like. Meaning, like a definition would say, hey, here is how the thing is implemented. So if we had a template and we included that within a function, excuse me, like template type name T, and then include T in the thing, then we can pass it anything and it'll sum the T's properly. So we could have type name T and type name Y, and then include T and Y. I don't know why I'm doing, or a T, and then so we'd have T of X and then T of Y. So we could pass in any two, and it would be that type. I like Aurora's definition. One or more placeholder types. Yeah, the placeholder type is because we don't know what type we're going to get. Yep. But will be provided later when the template is used. Okay. A template is defined. The compiler can use it to generate as many overloaded functions or classes as needed. Holy shit. And so, yeah, it says the compiler is doing that. Therefore, that means that it's done at compile time. And hey, we're calling the function with an int and a double. Oh, what does that look like? Oh, generate a function for that. Oh, we're calling it with a this and a that. Oh, here's another. Something like that. Oh, and maybe we do type name T, and then we do something, something. And then we call it with TX and TY. Oh, shit. Type name T, two different versions, yo. Issue. Like, doesn't that look like template, type name T? And then int max T X T Y. Uh-oh. Uh-oh. That's not it. That's not how you do it. Does it need to be... Why is it replacing? Okay, that's annoying. Well... Uh-oh. Oh! No semicolon. Oh shit. And now what happens if we say max 3 and 3.4? Uh-oh. Yes! No matching overload found, yo. Because it can generate all the options. It can generate an int one. It can generate... let's just say it returns y. Fuck it. It can do an int one. It can do... a float one. Oh, fuck. Hold on. Oh, oops. Oh, T! Can we do a T? Oh shit! We can do T. It returns the common type of these two. But if we do this and turn it into a long double, wait. Oh shit. It's still. Oh, because these are both default doubles. What if it's still? Because it's still a double. You don't get any longer than that. Still just a double. Okay. But if we do double and a float, no sir. There's no T in another. But if we did template type name Y, or a T in Q, and then QY, damn. Can't have multiple template clauses. Oh, maybe, and then type name Q, and then one clause. Boom! And now it returns X, so this will return a double, not a float. Boom. Boom! Returns a double, because we're passing a double. If we instead pass a float, boom, returns a float. Okay, templates are kind of cool. I like them. When are they used? We could say, like in a game, when would I use a template? It seems like it'd be in Unreal's deeper stuff where we're using characters and all kinds, like player characters and other things, like a template for this kind of object or this kind of object. Oh, like a template for, like what? Oh, like so maybe there are different types of characters. And maybe there are different hierarchies. Maybe some are children of other classes or... Oh, it's thunder. Ooh. Nice. So, different kinds of characters, which are different kinds of... They're different classes. So we could have like an enemy one, and then we could have like a goblin one, and that's a unique class. A kobold, that's another unique class. And then we could have human or player. Player is a unique class. And then we could have one function that has a template clause preceding it, and it's template type name. Yeah, I guess type name, because a class is a type, I guess, right? If I make a class, yeah, I guess so. If I make a class called a car, then car is a type, right? If we assume that and we say, hey, there's a type name, yeah, there's a type name, whatever the fuck. Well, and I use that in a function to like get the inventory of whatever character we're talking about. There might be some other crazy cast shit going on. Like in Unreal, you have to explicitly cast it to a specific type to see if it has an inventory or something. Maybe this is an interface. At least in Unreal, it could be an interface. You could check to see if it has an interface, but like I would need to call... I would need to check if the thing has... Yeah, like maybe I have a template for the different kinds of objects that work, and then an overload for ones that don't, or an overload to catch everything else. That way we can default to the ones that work, and for the ones that work, they have inventories, so we just return their inventory, because each one of those classes has a dot get inventory, and then it prints it. So then I'm using a template, and I can pass get inventory goblin 2, get inventory fucking player 3, kobold 1, kobold 48, and get the inventory of that specific object using its specific class. That's pretty fucking cool. Instead of having to say, ooh, I need I need to make a function. I need to make 3 functions, and they take 3 separate parameters. One takes a kobold class, one takes a character class, one takes a fucking ogre class. Instead, I just have a template. That's it. But then I still have to handle all the other ones that don't work, so I can't do invalid calls. Maybe. Maybe I don't need to, though. That's cool. Nice. Yes. So, yeah, and the end result's the same, but we don't have to maintain them. The compiler does it. Yeah, exactly. The compiler identically creates the rest. In a template, we can use one or more placeholder types. Yeah, so we use T or Y or Q or whatever the fuck. Some type that's not known, but will be known later once the template is used, which is when the function is actually called. Once a template is defined, the compiler can use the template to generate as many overloaded functions or classes. An overloaded class? What does that even mean? What does that mean? Generate a class? So if I have a class, but isn't the class its own type? The point is that a function is using specific types and it needs to handle and take specific types. But a class, how does a class take specific types? I thought the class was just. I thought it was its own type. So how would we generate other classes? I have no clue. There's some sort of or some faulty assumption going on in my brain. Okay. Each using different actual types. The end result's the same. Bunch of mostly identical functions or classes. That's cool. We only maintain the one. Cool. Well, it's not can. Motherfucker, it does. Well, it does depending on the use case. If we say template type name T, int max T X T Y, return, fuck it, return Y. X, return Y. Or, ternary, return X is greater than Y, semicolon, or question mark, X, semicolon, Y, semicolon. Or not semicolon, colon, Y. And we only ever call that with integer parameters, then it only ever generates the integer version. But if we do it with doubles and we do it with this and we do it with that and we do it everything else with matching types, because we're saying TT, same type, then it's only one. But if we call it with a double and with ints and with floats, we get three different versions: the int, the float, and the double types. Versions, overloads. What else am I learning in this chapter? Oh, class templates versus. Okay, I don't know what the hell that is. All right, it's a little while till we get to classes. Okay. Not even too much more. I'm surprised. Okay. The concept behind templates can be hard to describe in words. Well, templates are placeholder types for a function so that the operations with a function can be carried out with the parameters of whatever arguments or with the type with the data types of whatever arguments you pass to it. The parameters dynamic. Well, the parameters aren't technically dynamically adapting. The compiler is dynamically creating an overload for each type of arguments that you pass to it. And the template is a method for Basically creating overloads as needed, as dictated by the compiler, instead of you having to manually do all the overloading and maintaining. So it seems like it's an error reduction and a time reduction, time saving procedure. A pattern for creating similar objects. Yeah, template. Yeah, there's a template function, and it will create functions of its structure depending on some specific shit that you pass to it. Thin line of material with a shape. Yeah, we only create the template one time, and we can use it with different things on different materials. There's many different colors as you like. You can put it on this paper or that paper or this paper. The point is that the argument is the paper. We're putting the paper with the stencil, and the stencil is working. We're putting paper with the stencil, and it's also working. Or rather, you could say that the compiler is determining how many different colors you need. How many orders of different colors are there? Okay, let me put the template here. All right, we got a blue one now. Put it on here. We got a pink one. Oh, we got a white one. Oh, we got another one. Oh, we got a brown one, a black one. Cool. Yeah, the color doesn't have to be determined. It's like having a machine that automatically, or rather, no, you're just making it so that it doesn't care. We do what we need depending on the shit. And we do the same shit regardless. So yeah, it's just like a machine printing on paper. Nobody gives a fuck about the kind of paper. But we have to be ready for the different kinds of paper. Because if we only say we can accept white paper, man, we're missing out on other kinds of paper, yo. Extra types are not determined, or aren't determined until the template is used. Yes, not when it's written. Fucking duh. How is it gonna know? It's not gonna just generate one of a million types already. Make your compilation time take forever. Hey, you don't have to anticipate it. It can be used with types that didn't exist when the template was written. Yes. So later on, it gets called. Oh, okay. There's a new fucking type that has even more memory for an integer. Okay, cool. It just returns the fucking that new type because it's a template, yo. Hmm. How to create, how to explore how to create function templates and describe how they work in more detail. Okay. Class templates. What? Apparently not, buddy. We discussed classes in fucking chapter 4 and class templates pretty soon. I think it's next chapter. Well, it's not function like. It's a function, bro. It has all the shit that that function is going to do. It's just that the types it's using when it's executing isn't known yet at the time of being written. And if there's already an overload and then there's the template, and we call it the default one, the explicit one, not the template, there's like a precedence. So if we have 3 overloads and then we have a template one, and we call the 3 regular ass overloads, explicit overloads, those work as is. The functions that the template generates are secondary. So if we call those, then we can handle those and make them not work or something. If I had an int and a float and a string version of something, some function, those overloads already written, and then a template one, and then I say in the template one, error, improper type used, well, I can still call a double, a float, and a string one, or an int, a float, and a string one, and those are cool. It's only going to call these ones because those aren't the overloads that I've made. So as long as we don't call these, we're good to go. it will detect all the other possible types. The primary template and the functions generated are called instantiated functions. Yeah, we're creating instances of functions depending on what we're actually using the template for. When we create the primary one, we use placeholder types. Type template parameters. Yeah, it makes sense. It's a parameter. It's called type name something. Informally called template types. A template type? I don't like that because that's like saying a function type. And a function type, if anything, I would say is the return value, not the fucking parameters. I'm calling it type template parameters. We use placeholder types for any parameter types, return types, or types used that we want to be specified later. Yeah, because in the function we could use t as the return type, or any of the other shit. Oh. Specified by the user, whoever's calling it. Three different kinds. Alright, well I guess we're done. Self-test later.